Hello everyone, today we're going to resolve LeetCode Daily question number 1007, minimum domino rotation for equal row. So it's medium problem in which we are given a row of dominoes, tops I and bottoms I, representative top and bottom halves of the ith domino. So a domino is a tile with two numbers from 1 to 6, one of each half of the tile. So we have even example here. We might rotate the ith domino so the tops I and bottom swap value. Return the minimum number of rotations so that all values tops are the same or all the values in the bottom are the same, so they should be equal inside of top or inside of bottom. If it cannot be done, we return minus 1. So in first example, with three slightly different dominoes, but mostly of them are representative of two numbers, and we will swap one number with two number, and we will swap four number with two number, and we will return 2 because it will require 2 steps for us to make all numbers equal. So here's representative in array view. You see that here we have 1, here we have 4. So we will need to represent 1 with 2 and 4 with 2 to make the numbers on the top the same. For example, here we have tops 3, 5, 1, 3, 2, 3, and bottoms 3, 6, 3, 3, 4, and we return minus 1 because in this case it's not possible to rotate the dominoes to make one row of values equal. So we will approach this with a morning story. Every morning in Sunrise Village, inhabitants greeted the day by aligning their domino tiles before dawn, tops and bottom showing numbers 1 to 6. One habit from the miracle morning teaches that a small daily routine can transform outcomes. Similarly, our goal is to find the smallest number of rotation flips needed so that an entire row shows the same number, either on top or bottom. Imagine each tile as a villager, chosen to stand tall on its top or flip to reveal the bottom. If neither side matches the villager's chosen lucky number, the tile must be removed from consideration, ending the dream. We only need to try two candidates, whichever numbers already appear on the very first tile. By scanning once and counting flips from top or bottom appearances, we discover the minimum rotation, just like morning rituals that bring harmony to every tile. So this will be a greedy algorithm. And as you understand, we will make it in one pass, which means laxity be big of n, and as we don't create anything additional, laxity will be big of 1. So in this way we will first of all make a function to check every tiles that show target. On one row we will return flips or minus 1 if it's impossible. So we will define our check. We'll have our target, which represent integer, and we will return integer. We will have our values to check top flips and bottom flips, which will be equal to 0. Then we will look for T and B, and zip tops and bottoms. So if t not equal target and b not equal target, then we understand that it is possible to do, and we return -1. The next step will be check each side separately. So if t not equal target, then top, these will be incremented by 1. Else if b not equal target, bottom flips will be incremented by 1. And lastly, we will return minimum value from top, flips, and bottom. Flips. And so our goal to check the less of operation to achieve our target. So the next steps will be declare our result should be equal to check tops at 0. Then if results not equal -1 or tops 0 equal bottoms 0, we return res. Otherwise, we will try bottom 0. So return check bottoms 0. Very simple implementation. So let's run our code. Oh, a slightly typo. Bottom flips. Yep, this time look fine. Let's run. There are no other typos. Great. And submit. And it's pretty efficient. So the idea here is to make sure that we make the less possible operation. As with any greedy algorithm, we use check function to check each side. Firstly, we will start checking the top and return the minimum operation. If top isn't good value, so for example, if tops return -1 or other things, then we will proceed with checking the bottom. And we will find if we will define a result, we just return -1 by the end. Alright, thank you for your attention. If you have any question, feel free to leave them down below, and have a nice day. Bye.